This is a brief follow-up to my previous video, Acute View Angles at the Horizon. Mittelwell and Sable Eagle had some suggestions, so I thought I'd incorporate those and look at this a little bit more. Here we've got a model, and I have added a ceiling. It's just like the floor. And let's see, this is a 10 meter by 10 meter square. The checkerboard are 1 meter squares, and that column there is 10 meters high. I've got a viewpoint 1.7 meters above the floor surface, which is about eye level of a standing person. And then a second viewpoint directly above. It's at the mid-height of the wall structure here. I've marked out the view angles from the viewpoint to the bottom square of the wall and the last square of the floor, so that we can see the difference in angular dimension of those two viewing surfaces. And I've also put marked the degrees of each of these angles. So let's go to this point here, and we're going to be putting the camera right there and looking towards the wall. Oh, wrong one. Okay, there we are. So our viewpoint's 1.7 meters above the ground, and as you can see, that horizon line crosses just below the 2 meter block, so we know we're 1.7. We can see the bottom square of the floor, and we can see the bottom square of the wall. The wall is much closer to appearing to be a square, whereas the floor is very definitely being seen at a very steep raking angle. Now we're going to move up to the viewpoint that's halfway up the wall and notice what happens with the floor and the change in the floor. The ceiling comes into view. The floor and the ceiling squares are both closer to appearing to be a square, but still not as much as the wall surface itself. Now, we don't see our little viewpoint figure because the camera in SketchUp is actually placed exactly at that location, which means it doesn't appear on the screen. So I'm going to step back and to the side a little bit here so that we can see where we were. There. So that gives you an idea where we were, the two viewpoints we looked at. Now we're going to do the same thing on the other side, on the second model. It's basically identical, except that the wall is now 100 meters away instead of 10 meters away, so we've increased the distance tenfold. And we'll go to the two different viewpoints. Okay, we're going to go over to the lower viewpoint first. And so we're standing there looking towards the back wall, and we lose sight of the floor and the ceiling. Now, I should mention that, we're looking at this on a computer screen, so the actual limiting factor in this particular image, just to be 100% clear, is the pixelation of the computer screen. The pixels are larger than the limit defined by the Rayleigh criterion. So, you just have to accept that that's a limitation of the tool that we're using. However, I think the principle and the angles, the actual angles we're going to be looking at, point us to the real world results. So, as you can see, the closer the squares are to us in the floor and the ceiling, the more we can see them, and then they become more and more distorted as they move towards the back. However, the back wall still remains very easily and clearly visible, even though it's 100 meters away. Now let's move up to the viewpoint midway up the wall. Well, we're midway up the wall. Same thing, we're still losing the floor and the ceiling at the back. Now, at the suggestion of Mittelwell, I added a blocking object. And the top of that blocking object aligns with the line of sight from the viewpoint to the base of the wall. So it blocks the view of the floor completely, but it does not block the view of the wall. That's the blocking object. And Mittelwell wanted to point out that the nothing of the wall appears to change whether that blocking object is there or not there. Okay, now let's look at the actual angles that we're dealing with. We'll start with, I'm going to move to a orthographic view for a moment here. So we're in perspective view right now, and we're looking at a side elevation. There's the orthographic view of the same. And I'm going to zoom in so we can see it a little more clearly. That was our 10-meter observation. Let's start at the bottom. We have the angle, the angular distance for the bottom block of the wall. That measured at 5.644 degrees. The bottom meter of the floor is 1.048 degrees, so roughly a 5-to-1 ratio between the wall and the floor. Even though they're exactly the same size objects and at the same distance away from the viewer, we can see 5 times better the wall surface compared to the floor surface. So looking at the top of the wall from the middle viewpoint, we see 4.764 degrees for the view of the wall and 2.49 degrees for the view of the ceiling. So not quite 2-to-1, but almost 2-to-1, looking up at the ceiling from the midpoint. Now, of course, looking at it from the midpoint, if we were looking at the floor, it would be identical as the ceiling because it's exactly the same height. So I didn't bother to make the diagram overly complicated. Now, if we move to the 100-meter view, bring the whole thing into the picture here. There's our 100-meter view. And I'm going to zoom back in over here so we can see our numbers better. So our upper, looking at the lower viewpoint, our view of the 1-meter wall is 0.573 degrees. Our view of the point of the 1-meter floor in front of it is 0.01 degrees. So whereas before we had a ratio of about 5-to-1, just by virtue of moving back, that ratio has changed to about 57-to-1. So we can see the wall in proportion much better than the floor, 10 times better than the floor as we move away from it. So the wall becomes better, and compared to the floor, the wall visibility improves with distance compared to the floor. Of course, the angular view of the wall further away is less than the angular view of the wall closer. But the ratio between the wall and the floor angles favors the wall as we move away from the wall. The same thing is at work with the top view from the midpoint. We have 0.572 degrees for our view of the top block of the wall and 0.029 degrees for our view of the first part of the ceiling. So there the ratio is about 30-to-1. So again, it becomes much easier to see the wall compared to the ceiling. And all you have to do is look at it. Here we are. Take a look. The wall has got all of this angle of view, and the ceiling has got just that little bit up there. And we'll compare that to that. So the farther you get away from the wall, the more the viewpoint favors the wall and disfavors the floor. I believe that conclusion is directly opposed to conclusions that other people involved in these conversations have come to. And these conclusions, as I've shown them, are based on hard geometry and math and And were it necessary, I could do the trigonometry, but I really don't feel like it. And I think that the graphic approach works very nicely and is perhaps even more clear. So that's all. I've beat, again, this dead horse once more to death, and I've got other things to work on. So hopefully these pictures will be useful, and you guys can feel free to send me an email if you want a copy of the SketchUp file or something like that. If I can offer it, let me know. I'd be happy to help out. There's Middlewell's blocking wall. I like that. Makes no differences to the view of the wall behind. Okay, have a great day, everybody. Remember, hit the like button and let your friends know about this. A few more subscribers would always be nice. Bye-bye.